Impulse, as we talked about earlier, is a function of force over a time frame that the force is applied. This is usually when we do something to the system. For example, I kick a ball. I apply a force over an extended time frame. The time frames tend to be very quick. This is a punch, a kick, a hit with the bat, golf club against golf ball, something like that. Something where a lot of force is applied over a very short time frame. We use impulse when we're really interested in, we do force times time, but we're going to introduce momentum. Momentum is a vector, and it is the product of mass times velocity. Most of you have a fairly good idea of what momentum represents. You already know that a tractor-trailer moving down the road will have more momentum than a car moving at the same speed. I mean, you know that. Now, the reason why we're doing this product is because that's another way to discuss impulse. Impulse can be written as the change in momentum. Usually, we're not changing the mass. That doesn't mean we cannot change the mass. It means we usually don't. For example, when we're doing change in momentum, we're doing things like foot hitting ball. We're not changing the mass of the ball. We're just applying a force to go from zero velocity to a different velocity. Or we're bouncing a ball off the wall. Again, no change in mass, but the ball does have a velocity as it strikes the wall. The wall applies a force over a time frame, and then the ball moves in a different direction, thus changing the velocity, which is where this term comes from. And don't forget, change in momentum, change of always means final minus initial. And because these are vectors, direction must be taken into account. We cannot ignore something going right versus something going left. One of those has to be a negative, or else the setup will not work.